Expanding woody shrubs consisting of mesquite, creosote bush, tar bush into grasslands has been an important scientific and economic investigation. It has drawn the attention of many researchers using many techniques over many years. I'm Curtis Monger, soil geomorphologist, professor emeritus, New Mexico State University. A few years back, Jiaping Wang, then a PhD student, and I investigated yet another facet of using carbon isotopes to get information about vegetation in the prehistoric past. The overarching question of these studies is what was the vegetation before 1858? That is, before the land survey notes and the vegetation maps. Does an isotopic memory exist in Jornada soils that would enable us to address the question above? And if so, how long does the isotopic memory last? This was a question posed by Bob Gibbons in the late 1990s and is primarily the focus of this investigation. So, number one, does an isotopic memory exist in the Jornada soils? We have to say yes, and why? The grasses at the Jornada are warm season grasses that use the C4 photosynthetic pathway. In contrast, the woody shrubs, mesquite, creosote bush, tar bush, use the C3 photosynthetic pathway. They have very distinctly different isotopic signatures. The organic matter that forms in the soil beneath these plants have the same isotopic signature as the plants. And if you follow down through the soil carbon dioxide into the pedogenic carbonate, those carbonate crystals also carry a signature of the plants that were growing on the landscape whenever the carbonate formed. So yes, there is an isotopic memory in the Jornada soils. 1920, Doñana Range gauge on the Piedmont slope just north of the Chihuahuan Desert Nature Park. A lot of black grama, some shrubs coming in at that time. 2014, same area, a little bit farther south. But where are the C4 grasses? The question that we're trying to address is if we take a soil sample, does the organic matter contain, and we use memory metaphorically, but does it contain a record of the grasses that existed there in the past? This study was primarily done at the Chihuahuan Desert Nature Park vicinity. And here we have a block diagram to show the three dimensions of the landscape. The picture that I'm going to show next was taken from this narrow basin floor that's dominated by tobosa grass, very much C4. But looking back to the west, and it appears like this. So we have the tobosa swell, linear depression, the Piedmont slope, now dominated by C3 shrubs. And in the Doñana Mountains, they have a mixture of C4 grasses, C3 shrubs, and even trees, juniper trees, are C3. And the tobosa swell is really the most dense C4 vegetative biome at the Jornada. And the reason I put this up here is to stress the point, and this is something that is very obvious, but it took us a long time to realize it. But when you go back into the paleo record, you have to remember how heterogeneous this Jornada landscape is physically, but also biologically. So if we go back to then the nature park vicinity and address the question about how long does an isotopic memory exist, and we look at the percent C4 based on the isotopic composition of the bulk soil organic matter. And if we start down in the tubosus swell. That sample, after run through the mass spec, indicates 96%, very close to what we have there. But whenever we hit the Bajada, the Piedmont slope, and start going up, this now is primarily creosote bush and other C3 woody shrubs. But the organic matter still carries a memory of a time in the past when this Piedmont was covered with black grama grass. So how long does it last? Well, since that picture was taken in 1920, here we are in 2020. So this was, results from 2014, so almost a century. But we can definitely say decades. That memory is fading, but still, these soils remember the time when C4 grasses dominated that landscape. Now, what if we go in the other direction? What if the shrubs are replaced by grasses? How long does the memory persist? And where could that possibly happen? Golf courses, like the one shown here. But better still, if we go south to New Mexico State University and investigate turf, lawn, or in this case, turf grass plots, we can use a much more controlled experiment. These are C4 turf grass plots established in 2008. And the vegetation surrounding these plots, this is still on campus, on the NMSU campus, but the vegetation surrounding the plots are creosote bush and some mesquite, but primarily C3. So this is 2014. The Bermuda grass plots at that time had been there for 6 years. And during that time, the creosote bush, of course, has been bladed over and the ground smoothed over and so forth. So what can we gain in terms of understanding an isotopic memory in this scenario? Well, first, let's look at the organic matter, the amount of soil organic carbon. So in the desert shrubs, we have this amount, which is 1.5 grams per kilogram. In 6 years, it bumped up to almost 3. So there's an increase, as you would expect, going from the desert shrubs to Bermuda grass. But in only 6 years, we had that increase. And if we compare that to the carbon isotopes, so here we have the per mil values, the delta C13 values on the left, and on the right, percent C4. So the desert shrub vegetation, just running it through the mass spec, indicates that there's about 22% organic matter from C4. Okay. In the 6-year period, the turf grass has bumped that up to 66% C4. And presumably at this rate, not too many years, it'd be 100% C4 if those Bermuda grass plots stay in place. If we look at the calcium carbonate signature, okay, again, if we look at the amount, as you go from the desert shrubs to the turf grass, there was an increase in the amount of calcium carbonate that formed in those turf grass soils. And there's also an increase in C4 indicated by the isotopic signature of calcium carbonate in those topsoils. Okay. Now, this area around the NMSU campus, wasn't it a former grassland? I mean, this is what we hear. We hear that all of southern New Mexico basically was a C4 grassland, some 100 years in the past. And let's presume, yes, that was the case. And We know we can't travel back in time, but we can travel in space. So if we go to an area that we think the native vegetation now would be representative of how it was in the mid 1800s, we could go to the Summerford Piedmont Slope site. There are many difficulties with making this assumption, but recognizing that it's a very much an oversimplified assumption, we'll just use it for now. And this will be our native grassland site. So I'm just adding to the graphs that I've already shown the native grass. And so we would presume that as the grass was replaced by the desert shrubs, there was a decrease in the amount of carbon. And we would presume that there is a decrease in the amount of C4 grass. So that's the case for organic carbon. For inorganic carbon, there was actually an increase in the amount of calcium carbonate going from the native grass to the desert shrub. And we can't say anything about the isotopes because there wasn't enough inorganic carbon, enough calcium carbonate carbon to get an isotopic signature. So what is this saying? Well, a couple of things. One, I want to point out that there's a pretty rapid increase in the, not only in the amount of carbon that accumulates, both organic and inorganic, but a pretty rapid imprint of the signature showing the relative amounts. The other point about this slide is that the native grasslands, our best C4s, still aren't pure C4s. And if we take a look at the Summerford Bajada, which is one of the best black grama grasslands still remaining, there's a lot of C3 in that, like these poppies, a lot of forbs and succulents coming up also have the C3 photosynthetic pathway. So back to the questions. Okay, yes, we have an isotopic signature. How long does it last? You have to say it's variable. If a land surface is buried by sediment, either windblown sediment or water deposited sediment, that signature could last for millennia if it's out of the zone of soil formation. But if we go back to the big question, the big overarching question, and that is, can this technique tell us something about the vegetation before 1858? And for that, we really need a good stratigraphic record. And the best stratigraphic record is on the Fan Piedmonts. And the classic one that we've been able to find is on the Summerford Piedmont grassland. And here we have a 6 meter deep, 20-foot-meter deep trench. And we know about how old these layers are because they can be correlated to volcanic ash deposits. So we know that we're looking at the Coronado 1 surface about 600,000 years. So we're way back into the Pleistocene whenever we get down here in these soils. Okay. And if we use the carbon isotopic method as an indication of C4 plants versus C3 plants, if we zoom out, look at it in a with squinted eyes, knowing that this is a very rough, a very crude method, but nevertheless, I think we can say that since the mid-Pleistocene, we're looking at a landscape that is a semi-arid grassland. And I say semi-arid, to get carbonates forming, you really don't get those in humid environments. There's a lot of dissolution that's occurring in some of these old layers, indicating wetter time periods where the carbonates were dissolving. But overall, it was a semi-arid grassland would be our conclusion. So To go back to the slide really that we began with, what was the vegetation for 1858, with the caveat that there's a tremendous amount of detail that still needs to be investigated. We'd say it's primarily a grassland. Thank you.